In this video, we will cover what a new startup called Swarms is all about. This video will be comprised of two parts. In part one, we will give a non-technical overview of what the company Swarms does. We will showcase the industries the company is helping, the history of the founder, where the company is headquartered, and the primary initiatives the company and its community supports. In part two, we will showcase several tools available in the Swarms ecosystem via 3 demos. The first demo will showcase how you can use Swarms' low-code UI for performing social media marketing. The second demo will showcase how you can leverage Swarms for performing research. Particularly, we will look at the use case of financial research. And finally, the third demo will showcase how you can use Swarms for code generation. Particularly, we will look at the use cases of technical documentation writing and automated testing. Enjoy. Swarms, or the Galactic Swarms Corporation, is a company headquartered in Palo Alto, California. The company was founded in March 2024 by Kai Gomez, a Cuban-American coding prodigy who grew up on the borders of Hialeah and Opa-locka. And at the time of recording in September 2024, Swarms founder and CEO Kai Gomez is 20 years old. For those who don't know about Hialeah and Opa-locka, they are neighborhoods in the northwestern part of Miami, Florida. Anyways, let's now explain the origin of the company's name. To everyday people, Swarms will be thought of as virtual assistants or groups of AIs. But to define the term swarms or multi-agent systems a bit more technically, first let's define an agent. In the context of this video, an agent is a system comprised of the following parts. A, an LLM, which is a specific type of system capable of natural language interactions. Don't be fooled into thinking LLMs are magic though, as they can be broken down into further subcomponents like embeddings, attention, positional encodings, softmax layers, training, etc. B, tools, which are the integrations made between LLMs and the outside world. C, memory, because believe it or not, LLMs do not have memory. And D, prompts. Prompts are the messages we send to LLMs that influence how they achieve our goals or generate our desired output. When you combine multiple agents together in different combinations, you get what is called a multi-agent system or a swarm. Okay, enough mumbo jumbo. Let's now take a look at what Swarms does from a company perspective. First and foremost, Swarms is a business that helps enterprises automate internal operations by leveraging swarms of agents. Second, Swarms supports an open source Python package called, no surprise here, Swarms, that is seeing great traction since being released July 5th, 2023. According to CEO Kai Gomez, the biggest use cases the company is seeing for the Swarms package would be A, marketing automation, B, financial research, and C, code generation. To date, the Swarms Python package has garnered over 1,100 stars on GitHub, has been downloaded over 1.2 million times, and has received contributions from over 20 developers around the world. Third, Swarms supports an open source marketplace available at swarms.world, where members of the Swarms community can share prompts, agents, swarms, and tools with each other. According to CEO Kai Gomez, the Swarms marketplace has over 1,000 users since launching April 2024. And finally, fourth, Swarms supports a Discord server called Agora Lab, where regular online seminars and discussions are held by community members for exploring open source AI research. To date, the Agora Lab Discord server has over 8,300 members. In the next part, we'll showcase 3 demos that highlight various tools available in the Swarms ecosystem. Okay, here we go. Exclusive access. This tool allows us to build a team of virtual assistants. When I say virtual assistant, I mean agent. When I say team, I mean swarm. So team member is to team as agent is to swarm. Hopefully that makes sense. The way we add agents to our swarm is, we can actually do this in 2 ways, but the first way I'll show is by clicking this add agent button. This gives you a field where you can customize the team member or agent. Each team member is going to get a name. And here is where you can specify the team member's persona. So we will say, you are great at producing content for LinkedIn. Before I click this button to update the swarm, we also have to define our flow. So the flow defines how the messages we send to the swarm are going to flow through the swarm. We only have one team member in our swarm at the moment. So we have to specify the team member like so. This means that when we send a message to our swarm, this team member will receive our message, generate its output, and return the output to us. Now I can update the swarm, right? And if I say hello, you can see our agent is responding accordingly. Let's now add another team member or agent to our swarm. Team member 2. And this team member will be great for marketing content on, let's say, X, aka Twitter. Here we'll add a comma, then specify the second team member. What this means is that when we send a message to our swarm, the message we send will be received by the first team member and by the second team member in parallel. If we were to specify an arrow here, what this means is the message we send to the swarm would be received by the first team member. The first team member would generate its output, and the output of the first team member would be passed to the second team member. The second team member would generate its output and would return it back to us. Most of the time, you're going to keep this very simple, but sometimes you can do cool things by tweaking how the message flows through the swarm. We'll keep it simple for now. We'll edit the swarm, and let's say hello again. And you can see each team member responds in parallel. So defining our swarm manually, like we've been doing, is great, but we actually have another option, as I hinted at the beginning. We can use this swarm builder to generate a team for us, given a prompt. Let's specify this prompt. Create a team of expert digital marketers specialized in producing content for the following platforms: X, Facebook, Instagram, and LinkedIn. The content each marketer generates should be hyper optimized for connecting deeply with the intended audience. Let's run the swarm builder and see what happens. So you can see our agents have been created for us. And the swarm builder also suggested how the messages we send to the swarm should flow through the swarm. And it kept it very simple. No surprises there. So now if we update the swarm and send a message to our swarm, for example, let's send this message. Market a new web application called Swarms Playground, available at demo.swarms.world. You can see the Twitter marketer gives us some content for Twitter. The Facebook marketer gives us some content for Facebook. The Instagram marketer gives us some content for Instagram. And the LinkedIn marketer gives us some content for LinkedIn. So this is amazing. This, just a couple months or years ago would have taken hours, if not days. That gives you a good overview of how this tool works. Let me show you this other tool, which is also very useful for content generation. So here I have preloaded a swarm that is specialized for marketing on various social media platforms. And what this swarm does is output the generated content for each member of the swarm into a spreadsheet. So if I send this message again, market a new web application called Swarms Playground, available at demo.swarms.world, we can see each of the marketers generating its output. And when all of the marketers have finished generating their content, we'll be presented with a spreadsheet that we can download. We can download the spreadsheet and import this into any tool that is capable of reading spreadsheets. And this is fantastic because we can pass this on to other team members who can edit this and make sure it gels well with the overall brand of the company that we're doing this work for. The ideal profile for this set of tools we will demo from the Swarms ecosystem would be an analyst or researcher who is looking to digest large amounts of data. The problem these tools are aiming to solve would be the data limitations of LLMs. LLMs are only designed to process a limited amount of data per interaction, and studies show the more data you pipe through an LLM, the more inaccurate its results will tend to be. Here's a table showing 4 popular LLMs and their context windows. We're using a conversion ratio of 0.75 words to 1 token. While these context windows are impressive, they don't tell the full picture. This research paper, published March 2024, referred to as the long agent paper, according to my understanding, reports that as more data is sent to an LLM, like for example those of the GPT and Claude families, recall accuracy degrades. Let's take a closer look at the results for GPT-4. In the rightmost column, we're seeing the results of piping in about 300 pages of data and asking questions about information present at various depths. Here, for example, we're asking a question about something, let's say, halfway through on page 150, and we're seeing that the LLM answers accurately less than 50% of the time, as indicated by the red color. In the leftmost column, we're seeing the results of piping in about 3 pages of data and asking about information, let's say, about halfway through page 2. And we're seeing that the LLM answers accurately about 90% of the time, as indicated by the green color. Zooming out, what these charts are telling us is that as we pipe more data through LLMs, their accuracy in terms of information recall degrades. My understanding of why LLMs behave like this is due to the high costs of training on longer input data. These high costs cause companies to avoid longer data when training. If you can shed more light on this matter, please leave a comment. I would love to learn more. The approach used in the long agent paper for increasing accuracy in terms of information recall consisted of, who would have guessed, leveraging groups of agents or swarms. The swarm described in the paper consisted of one agent designated as the leader, whose MO was to delegate subtasks to one or more worker agents, where each worker was given a different chunk of some overall data. After the leader agent received the delegated outputs of the worker agents, it was directed to deduce the final output. Okay. You now have enough background information to appreciate what this chunking tool we're about to show, built by Swarms, does. For this demo, we'll be using NVIDIA's 2024 quarterly SEC filings as our test data. This is how we use this chunking tool. First, we drag and drop our files. Second, we customize our request. Here are the prompts that we'll use. This is the prompt that gets sent to the workers along with their delegated chunks. And this is the prompt that gets sent to the leader. And this prompt will be executed after the leader receives the output of all the workers. We'll leave these as default, and we'll go to the next step where we can review our request. Here we see our files. Here we see our prompts. And this button will send our request to our swarm. Here are the results, and supposedly NVIDIA, according to GPT-4o Mini, is killing it. Here's a graphic walking us through what just happened. What we just did is use Swarms' overall chunking tool. This is great for having an AI analyzer process large groups of documents. The use cases for this tool would be analyzing financial reports, analyzing resumes when hiring, analyzing health records, etc. Here's how it works. Step 1, you provide your data organized into files and 2 prompts, prompt A and prompt B. Prompt A is what gets assigned to the workers in the swarm. Prompt B is what gets assigned to the leader. This is the prompt that gets ran after all of the workers finish generating their outputs. The final thing you need to provide is the LLM you want to use. For example, Claude or GPT-4 or Llama 3. In the previous example, we used GPT-4. Step 2, Swarms will split the files that are too large to send to the desired LLM into chunks. Step 3, Swarms applies prompt A to the chunks of each file sequentially, with the output of processing a chunk passed as context when processing the next chunk. This is so the LLM has an overall sense of the file. Step 4, after all of the workers are finished generating their outputs, aka after prompt A has been applied to all of the chunks, we are left with the output of analyzing or processing each file in the batch of files that was uploaded to the chunking tool. Step 5, we apply prompt B, which is the overall prompt or the final prompt that the leader applies to the outputs of all of the workers or all of the chunks. And this gives us our final result. Because Swarms' framework is model agnostic, we can mix and match LLMs when building our swarms and analyzing data. Let's now configure the agents in our swarm to use Claude instead of GPT-4o. First, we drag and drop our files. Second, we configure our request. We're going to use the same prompts as before. This is the prompt that gets sent to the workers along with their delegated chunks. And this is the prompt that gets assigned to the leader. Here is where we can specify the LLM used by all of the agents in our swarm. Let's switch GPT-4o Mini to now be Claude 3.5 Sonnet. Click Next. We review our request and we send our request to our swarm. Now we can compare and contrast the outputs of our swarm when it uses different LLMs. On the top, we see the output of GPT-4o Mini. On the bottom, we see the output of Claude 3.5 Sonnet. You can see that both of these swarms that are using different LLMs under the hood are relaying some of the same information. Trusting one LLM all the time seems a bit unreliable. Let's showcase one last feature of this chunking tool that will allow us to stay even closer to our data sources. The feature I'm referring to is called per-page chunking. The process of how we do this is the same as before. First, we drag and drop our files. Second, we configure the request that's going to get sent to our swarm. We'll be switching the mode of our swarm to be per page. What this mode does is apply a prompt to each page of any paginated files that are sent to the swarm. So what we can do is use a swarm like this. Summarize the content, which is one page of a larger 2024 Q2 10Q SEC filing by NVIDIA in a way that is easily comprehended by a high schooler. A prompt like this allows us to generate on-demand cliff notes of arbitrary data. We can also do prompts that allow us to search through documents in a more natural way. But anyways, let's run this and observe the output so you get a feel for how this works. We review our request and send our request to the swarm. Here is what the results look like. We can see that our prompt has been applied to each page of this document. Because the amount of words on a single page tends to be between 300 to 500 words, per-page chunking can yield more accurate results compared to other methods due to how LLMs currently work. Here's a graphic that walks us through what just happened. What we just experienced is what the Swarms ecosystem refers to as per-page chunking. Per-page chunking is great for searching across paginated data like PDFs and for generating on-demand cliff notes. Here's how it works. Step 1, we provided our data organized into files, our prompt, and we also selected the LLM we want to use. For example, Claude, GPT-4, or Llama 3. Step 2, Swarms split the paginated files so that each chunk was equal to one page of the document. Swarms then looped through and applied our prompt to each page. Finally, we will return the output of the LLM processing each page of each file in our batch. While this chunking tool might seem abstract, according to Swarms CEO Kai Gomez, it is experiencing, among other tools in the Swarms ecosystem, traction in the financial and market analysis space. And in this demo, we will show how we can use groups of LLM agents or swarms for code generation. We'll showcase some amazing techniques that we can use for A, documentation writing, and B, automated testing. We will feature the use of Python and a little bit of Node.js, but you can adapt these techniques to other programming languages and frameworks, assuming the LLM you're using was trained on sufficient amounts of data. These examples were inspired by two scripts found in the Kai Gomez Swarms repo on GitHub. The first being the autodocs script, and the second being the autotests script. First, let's take a look at how we can use adapted versions of this autodocs script. Here we have the code for some API powering some web application. Let's now show how we can easily document this code by leveraging LLMs. At the root of this project, you can see we've included an empty scripts folder. Let's now add this amazing script that is going to allow us to easily document this code base. This script allows us to list all of the files in our project that we would like to generate documentation for. We have to define the path for each file, as well as the name of the final generated documentation file that will explain how the code in the file works. The type of documentation we will be generating is called Markdown documentation. Markdown documentation is compatible with many popular documentation site builders, like for example, Docusaurus or MakeDocs. Here, we can see that for each file, we are sending it in parallel to an LLM agent for processing. This is the prompt that we use to define how each agent in our swarm works. You can see that we are giving each agent the persona of a technical writer with decades of experience, and that we're also including our code as well as some contextual information about the application in which the code sits, like for example, the overall application schema, as well as all of the routes on our API. After each agent has finished processing its file, we will write the final generated markdown into a scratch folder at the root of our project. We can then copy this final markdown into popular documentation site systems like, for example, Docusaurus or MakeDocs. Let's see how this works. First, we run the script. Second, we generate a documentation website using a documentation website builder like, for example, Docusaurus. TypeScript all day. Third, we copy the generated markdown files into the relevant areas of our documentation website. For Docusaurus, this is the docs folder. And fourth, we run the documentation website and make sure it works. And here we see our documentation. And honestly, for no effort, this looks amazing. Of course, you're going to have to refine this generated content and massage how it looks on your documentation site. But as I said, I think this is an amazing technique for generating documentation. We will now show how you can leverage multiple LLM agents, aka swarms, for performing unit testing on your applications. In my experience, leveraging LLMs for this use case rarely goes smoothly, but I still find it worthy of sharing with you as a huge productivity boost. We will be using this fast API project for this demo, and at the root of this project, we have a scripts folder in which we can place utility scripts. Let's add this gen tests script that was adapted from the autotest script found in the Kai Gomez Swarms repo on GitHub. We can see this script allows us to list classes in our project for which we would like to generate tests. Each listed class will be sent in parallel to an LLM agent who will read its source code and generate tests for it that are compatible with the PyTest testing framework. Here is the prompt that we're using to define the persona for each agent in our swarm. And you can see we're giving each agent in our swarm the persona of an expert software engineer specialized in writing tests for Python code bases. You can easily tweak this prompt if Python is not your preferred language. Let's now run this gen test script on the most core class of this API, that being the agent class. Wink, wink. We can see that the LLM has generated some code that appears to be compatible with the PyTest testing framework. Let's flow through the process of how an engineer would use this generated testing file so you understand the overall process being presented in this video. First, you would copy this testing file to the tests folder at the root of the project. This has to do with how PyTest works. Next, we would take a look at this code before running it to make sure it's not doing anything dangerous, quote unquote. For example, it's not going to delete any files on our computer or do something weird. And after auditing it, we can run it. At this point, we have two options of what we can do. Option one, we can go through and delete all of the failing tests and call it a day. Or two, we can go down the rabbit hole of fixing all of the broken tests until this test suite works exactly how we would like it to. Depending on the nuances of your application, I could see how both approaches could be valid.